Hey, what is going on, guys, and welcome back. So, we are doing the final exercise in section 4 of part 5, which will conclude part 5 in our progression in the course. And this exercise, I generally needed some time off screen to think about it because the instructions, as we'll read them, aren't that descriptive. They're very open ended, which, again, isn't necessarily a problem because programming in general is very open-ended. We've mentioned this before in the past where, for example, in the world of building websites and web applications, you can use, four different tech stacks, and still reach the same look and behavior of your web application. You can use Next.js and still create a full stack application. You can use Vite with an Express backend or a Python backend. You can use PHP and JavaScript and all these other stuff and Apache and still be able to create a full functioning web application. So, this is an example into what programming really is. It's an open-ended, assignments are open-ended. Sure, they might have constraints and guidelines. Maybe they want you to use specific tools and specific languages and specific tools, but for the most part, when you're working on projects or when you're doing exercises like this, sometimes you're going to have these scenarios where the requirements are very open-ended. You just have to get to a final output. So I had to break down this question, this challenge really, into chunks and figure out where we've seen certain aspects of what we're doing to be able to get to the final conclusion or to the solution that I think will be acceptable. So the exercise is called a square of letters, and we're instructed to basically the instructions read as this final exercise in this part is a relatively demanding problem solving task. It can be solved in many different ways, which is again goes back to the what I just mentioned earlier about the open-endedness of programming and programming challenges. Even though this current section in the material covers tuples, tuples are not necessarily the best way to go about solving this. And the solution that I was able to think of doesn't involve using tuples. Please write a program which prints out a square of letters as specified in the examples below. You may assume there will be at most 26 layers. So our program will function as this. We're going to prompt the user for an integer that has something to do with this term layers. And from there, the program is just going to output this, right? It's a square of letters, essentially, and that's really what it means. Not the square root, not letters squared, like C squared or whatever, but it's supposed to really look like a square. It's harder to see it like this because there's no spacing. But if I go to the Python playground here and I just paste this in and add some spacing, it might be a little bit easier to see. So now you can see it. This is much closer to a square visually than this is. So that's what we're going to be printing. So you may assume there'll be at most 26 layers, and this is a pretty big clue. So as you can see, when a user inputs 3 layers, right, we have the square printed out. Now, there's a couple of things we're going to have to determine here, and one of them is the size. The size of the square, and what goes where, right? How do we determine what letter goes where in the square? So currently, as we're looking at it, you can probably start to seeing some patterns. In fact, I'm going to go ahead and also paste this so you can to make it a little bit clearer. So we'll do the same thing. We'll add some spaces so we can see this squares a little bit better. Okay, so take a look at this square, for example. First, the smaller one, right? The outer ring of the square is the letter C. Then, when we move inward, right, when we move one row down and one column inward, that ring has a bunch of B's. And then when we move one more row inward and one more column inward, which gets us to the middle, the center, we have the letter A printed. Let's look at this square. The outer ring has all letter D's, right? Then when we move one row and one column inward, we see a ring of all C's. Okay, and then when we move one more row and column inward again, we see column B. I mean a ring of B's, and then the final center letter is always an A. So now we're starting to notice some things. So I'll paste this in here, this little table, so we can be able to see two things: the layers and determining the square size. So when we have 3 layers, so over here, our square size is 5, right? We have a 5 by 5. So let's count it. 1, 2, 3, 4, 5. We have 5 columns. 1, 2, 3, 4, 5. We have 5 rows. When we have 4 layers like this, we get a square that's of a size of 7. So we have 1, 2, 3, 4, 5, 6, 7 columns, and we have 1, 2, 3, 4, 5, 6, 7 rows. So we have a 7 by 7. Here we have a 5 by 5. And we could probably continue this, right, just to see it a little bit more. Say, for example, we have layer 2. So that means we're going to have a square that's a 3 by 3. So, which means will basically be this. So I'll have to go ahead and remove all of the outer C's, like that. Remove this row, like that, and then go up here and remove the first column. And I'll just bump this up a little bit. So now, this is what happens when we have layers 2. We have a ring of B's, and the center is A. And if you count the rows and columns, we have 1, 2, 3 columns, and we have 1, 2, 3 rows. So now this makes sense. And then again, if we had only 1 layer, then guess what's going to be printed? Just the letter A, right? Because as you can see from our table here, when we have 1 layer, we get a square size of 1. So we have 1 column and 1 row. So now basically this is how we can determine the size. So again, let's look at our table here. When we have 1 layer, we get 1 square size. When we have 2 layers, we get 3 square, a square that's 3, a square size of 3. When we have 3 layers, we have a square size of 5. When we have layers 4, we get a square that's 7, a square of the size 7. So we need to be able to determine what size equals to, and we can use our information from the layers and the layers to be able to determine what our square size is. So let's look at our square size here, right? The size is 7. So basically here we're trying to say 7 is equal to how can we get to this number 7? And we get there by doing layers times 2 minus 1, right? So let's put this to test. So let's say, for example, a size of 1. That would be 1 times 2 minus 1, right? 1 times 2 is 2. 2 minus 1 is 1. When we have 2 layers, if we want to get a square size of 3, then we need to do, and that is determined by having 2 layers. So we do layers, which is 2 times 2 minus 1, right? 2 times 2 is 4. 4 minus 1 is 3. That's how we get a square size of 3. How do we get a square size of 5? 5. Well, that's based on inputting 3 as our layers. So 3 times 2 minus 1, right? 3 times 2 is 6. 6 minus 1 is 5. Again, square size of 7, and that's 4 times 2 minus 1. What's 4 times 2? That's 8. What's 8 minus 1? That's 7. So that's our formula for determining how big these squares will always be. So let's put that to use. So we have our formula here. I'm just going to copy this, and I'm going to erase everything here, right? So first, our program will have to prompt the user for the layers. So we're just going to say layers is equal to, and we know that layers will always be an integer, so we can just typecast integers input layers like that, and then we're going to determine the size, which is that formula we came up with. And so now let's where in the past, and this is one of those questions that I had to ask myself, well, where in the past have we learned how to print squares? Well, in section 5, in one of the exercises when we're practicing writing Sudokus, right? So this function here that we wrote to print a Sudoku uses nested loops, right? We have an outer loop that determines for our rows and an inner loop for our columns, and then we print something in it. Let's go back to the Python playground here, and I'm going to say for row in range of the size and for column in the range of size. And then we're just going to print, zeros. And we're going to do that, and then I'm going to print an empty space here. So now when we run this, it's going to prompt us for the layers. We're going to write 3, and there we go. Now we have a square that's 5 columns wide and 5 rows deep. So now we need to determine, well, how can we determine what letters to put here? So what we're going to need to do, actually, in fact, let's actually not even worry about the letters, right? Let's talk about the positioning here, and I think it might be a little bit cleaner if we were to do something like this. Row, right, to simulate a tuple here, row, column, right, and let's run this. Okay, so now we can see this grid. It's still a 5 by 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But now we're seeing coordinate points, right? We're seeing the grid as a coordinate. So given a row and a column, how can we determine what letter goes in what position? So let's think of this as our okay. I'm gonna put this little. I have some notes again off screen, so I'm just gonna place this little grid here. So when we look at this little grid, this square here, well, what do we notice? In the outermost ring, it's a bunch of zeros. The inner ring is a bunch of ones, and the innermost column and row, right? This position right in the middle is 2. So the outer border, what I'm trying to simulate here, the outer border here, this outer edge, is 0 squares from the edge, right? Because this is the edge. And then when we move inwards, 1 row, 1 column, well, we're 1 step away from all edges, right? Say, for example, this position, which is 1, comma 1, right? This position, well, we are 1 column away from the leftmost edge, and we are 1 row away from the topmost edge. When we look here in the center, well, the center, which is 2, comma 2, well, this is 2 columns away from the edge, and it's 2 rows away from the top edge. So that's what we need to be thinking about, right? We need to be able to use the distances of each position in our grid, in our square, to determine what letter goes there, right? If we can determine how far we are from the right edge, the top edge, the bottom edge, and the left edge, that will help us determine how or what letter will go in each given position. So, take for example, this position, right? 1, comma 3. 1, comma 3 is 1 row from the top, and it's 1 position from the right. So this one, right? So if we were to look at this in terms of inputting letters, well, what letter will be the likeliest candidate here? So we know that we have 3 layers, right? In this example, we're inputting 3 layers. So that means that if we were to map this to the alphabet, so A, B, C, D, E, F, G, well, with 3 layers, then that means, right, 1, 2, 3, then that means C will be the outermost letter. So these zeros will turn into a bunch of C's, and then, since we're moving 1 position to the left and 1 position down, then we'll need to go 1 position to the left of the outermost letters, which will be C. So now every letter here that has a 1 will be the letter B, right? And now we move again 1 more row inward and 1 more column inward and 1 more row inward. That means we need to move 1 more position beyond the edge, from the edge. So now we need to move 2 positions from C. And that's how we determine that A goes here. So now we need to start determining these positions. And we're going to create some helper variables here, right? So one thing we can always know that from the top, we're always going to be equal to the row, right? So if we're at row 0, then the distance from this edge will be equal to the row, right? So so the distance from the top will be 0. And if we're at row 1, then the distance will be whatever will be equal to that row as well. So when we are at row 1, right, if we're at this position, 1, 1, then we know our distance from the top is 1, and our distance from the left will be 1. So top and left will be equal to our row and columns respectively. Okay, now how do we determine how far we are from the bottom? So, right, that's the mystery number, and how do we determine how far we are from the right? Pardon me, not row, from the right, right? Well, we can just do some simple arithmetic to determine how far we are from the bottom. So from the bottom, that would be, say for example, this position here, right? 1, 1. Well, how far are we from the bottom? Well, we can do the size minus what row we're on minus 1, right? So if we're at 1, 1, then the bottom, which is at, will be 5, or size 5. Then what's 5 minus 1 minus 1? Well, that's 3. So, and if we look, how far are we from the bottom here? We are 1, 2, 3 rows from the bottom. So bottom will just be size minus row minus 1. And it will be pretty similar to how we calculate the right. But instead of using row, what can we use? Well, our columns determine how far we are from left and right. So we would do size minus column minus 1. So these are the 4 key distances that we need to be able to determine where each letter will go in our little square. Now I've given you the answer here, but it's again, let's look at it, from a position here. So if we're at 1, 3, right? Let me just copy this and I'll paste it down here. Right? If we're at 1, 3, and 1, 3, well then how far are we from the top? Well, if we're at 1, 3, then from the top we are 1 position away. If we're at 1, 3, how far are we from the left? Well, we are what, 3 positions, right? 1, 2, 3, right? We're 3 positions from the left. So this would be 3. Okay, and how many positions are we from the bottom? 1, 2, 3. So 3. And how many positions are we from the right? That's 1 position. So if we were to use our formula here, right? So the top is equal to the row, right? Top is equal to 1. If we're at 1, 3, then we are at row 1. Okay, the left is equal to our column. And what column are we on? We're on column 3, right? 0, 1, 2, 3. So that's why top is equal to row and left is equal to column. Okay, and how do we determine how far we are from the bottom? Well, we take our size, which will be 5 minus the row that we're on. We're on row 1, so this will be 5 minus 1, which gives us 3. And how do we calculate the right distance? Well, that's 5 minus what column we're on, which will be column 3. So it'll be 5 minus 3 minus 1, which gives us 1, right? So that's how we get to these answers. So that's just another way to think about it. Hopefully I'm making sense. It's a lot harder to explain it once you've put it down in your mind, but I'm trying my best. But this is why I wanted to show you these squares and coordinates before we start going forward. So these are the key distances we have to calculate, and we had to use some arithmetic here, right? Some basic math to determine how far we are from the bottom and how far we are from the right. Now, while this is good, in order to know what position we are, we have to basically get the smallest value, right? So this gives us coordinates, but it doesn't give us, distances, but it doesn't. We need to reduce this to one small value, right? The smallest distance from an edge, right? We don't care if it's right, top, bottom, whatever, but whatever the smallest distance that we can get from given these 4 distances. So how can we do that? Then we can just create a variable called distance, we use this function in the previous videos, right? The minimum function, right? This just takes in a bunch of values, and it would return what the smallest number from this list is. So, for example, for a layers of 3, it's going to plug in 1, 3, 3, 1, right? So it's just going to return one of the ones. It could be top, it could be right, it doesn't matter. It's just going to return the first smallest value from these given values. So in this instance, right, given 1, 3, 3, 1, distance will be 1. Right, the smallest, and this 1 basically is the smallest value, which will be the smallest distance from the edge, right? We want the smallest distance from the edge. So we're at 1, 3. The smallest distance will be either top or right, because we are one step away from the given edge. If we were closer to the middle, like if this was 2, 2, then it would be 2 spaces from the top, 2 spaces from the right, 2 spaces from the bottom, 2 spaces from the left, right? So 2 will be the smallest answer. Okay, now we need to map this distance to a letter. Well, how do we do that? Well, originally I was thinking we could use a dictionary, right? We've learned dictionaries, and it could be easy. Not easy, but we could use dictionaries. But here it says, please write a program which prints out a square of letters as specified in the example below. You may assume there will be at most 26 letters. So this is kind of a hint that we don't necessarily need dictionaries, right? We can even just use a string called letters, and that string could have all the letters of the alphabet. So, and we've learned how do we access letters in a string? Well, we can do something like this: letters at 0, right? This will return an A. Letters 1, this will return B, right? But instead of using letters, we can plug in distance, right? So if distance is 1, then letters 1 will return B, right? If the distance is 2, then so on and so forth. But because, and we'll get to that in a second, but because of how we're determining distance, we'll just have to do a little bit of further arithmetic here to determine exactly what letters, because we need to get the letter, not the letter equal to the distance, but the letter that we determine from using the distance to calculate where in the string to pull the letters from. And again, we'll get to that in a second. So, say for example here, right? We'll continue with a little example here, down here. So if distance is 0, then for layers 3, that is, right? Layers 3, if the distance is 0, then that means this has to give us the letter C. Because if you remember from our earlier square, where is it? Let me go back over here, copy this. I'll paste it here, and again, I'll do the same thing. Right? Distance is 0, basically the distance from the edge. So when we're at the edge, then the distance is 0, and that needs to give us the letter C. When we're at 1, 1, then the distance is 1, so that needs to give us the letter B, right? So when distance is 1, this needs to give us the letter B, so we can populate this position, right? And if we're at distance of 2, then this needs to give us the letter A. So how can we do that, right? How can we determine what letter to give if our alphabet starts from A? Well, we can do something like this. For example, the distance will be, the letter that we need to get will be letters, right? Layers minus distance minus 1. Right? We're seeing this minus 1 a lot, right? So for layers 3, then we need to do 3, okay? And given whatever position we're on, right? Whatever distance we determine. So for example, for our original 1, 3, then the distance will be determined. The smallest return value here will be the letter 1. So this will be 3 minus 1 minus 1, which will give us, what is it? 3 minus 1 is 2. 2 minus 1 is 1. So it'll give us a letter B. And that's how we determine that the letter B goes in this position, right? 1, 3. That's how we get the letter B. right? So, and then if we were at the edge, the distance will be 0. So what's 3 minus 0 minus 1? That's 2. So that gives us 0, 1, 2, right? It gives us the letter C. Okay, so we need to be able to print this. So we're gonna go here to our print statement. We're not gonna use an F string here because it's not necessary. We can just do letters minus layers minus distance minus 1, and that is going to give us this square. So I'm just gonna comment this out, and I'm going to run our program. So layers 3, there we go. We get C's on the outer ring, we get B's in the second inner ring, and then A dead in the middle. Okay, let's try with layers 5. We get a bunch of E's in the outside. We go 1 row and 1 column inward. We get D's printed. We go 1 row and 1 column inward again. We get the C's printed. So this will be the square of size 5. Then we'll go inward again. We get a bunch of B's printed. Then the center letter is always the letter A. Right? Let's try with layers 4. This is from our example. Right? From our example here with layers 4, the outer ring is D. The inner ring is C. Then the innermost ring is B. And then the middle letter is A again. And here we have A is in the middle, surrounded by B's, surrounded by C's, which are surrounded by D's on the outermost edge. So this is the answer. This is the solution right here. There's nothing more to it. We didn't need to use tuples. We didn't need to use dictionaries. We used strings, some basic arithmetic, and nested loops. And we were able to do that. And remember, don't forget this print statement that sits outside of the innermost loop. So that's what gives us exits. How to explain it, right? This was what determines that we don't print everything in one row, right? This is always basically telling Python, hey, go break off and go to the next line. And that's the solution. So I have VS Code already opened up, and we have the exercise here, the last exercise 27 in section 5. I'm just gonna paste our solution here. Gonna run our tests. And there we go. Send that solution to the server. We're gonna open the model solution in the browser as well. And there we go. So they are determining the distances as well, right? From the left, distance to the right. And then I'm assuming this will be distance from the left, from the top, and this will be the distance from the bottom. But again, they're using it to calculate distances from the alphabets instead of distances from the outermost edge. And they're using while loops. And again, this is a little bit messier than what we came up with, but it works. But I think between the comparison between our solution and the solution that the model solution is, and they also use an alphabet string, I think ours is a little bit cleaner and a little bit easier to follow. So, maybe for your own sake, you could probably say distance from top, distance from bottom, right? And then smallest distance like that. Maybe it might be a little bit easier to read, but this is what works for us. So that's it. That's the solution. The biggest challenge for me when I was trying to figure this exercise out was that how can I simplify this? How can I in my brain, how can I simplify this? And it was just, okay, well, what patterns do you notice, right? And one of those things in programming is sometimes looking for patterns. So I noticed that, hey, for a given square, then the outermost ledge will have the same letters, and then we decrement one letter in the alphabet for each inner ring that we proceed, right? So the deeper we go into our square, the closer to A we get in the letters of the alphabet, okay? Then the next thing will be, well, how can we determine how big the square is, right? And then that's how we came up with the formula for size, okay? And then after that, the challenge became, how do we determine what letter goes where? And I hope the visualization that I gave you guys here with the coordinate points, right? 0, 1, 0, 2, 0, 3, 0, 4, 1, 1, 1, et cetera, maybe made that a little bit easier, as well as when I had the squares up on the screen. But yeah, for me, the first breakthrough was when I stopped thinking about the letters and started thinking about coordinates. And I was like, hey, well, if we're building a square with these coordinates, where have we seen that before? Well, and I go back in the solutions, and this is why I have this GitHub repository for you guys and for myself, right? I use this GitHub repository that accompanies right? The videos that I'm doing, right? I have this repository up with all the solutions that we've done, all of them, all the solutions that we've done on the videos are in this repository, right? And I use them as references when I'm working on stuff, when I'm doing exercises myself, right? It's because before I start recording, I will go through whatever section it is and I will try to see what the exercises are like. And I'm looking for patterns, right? Have I seen something like this before? And that's when I remembered, hey, printing these squares, we've done this before. And when we were first learning about matrices and nested lists. And so we use nested loops to be able to print our Sudoku grids. So that's how I was able to determine, hey, we need nested loops here for printing our square. And then after that, the challenge, I mean, not the challenge, but um, once that mental model in my head became clear and once I started looking at everything in terms of coordinates, right? And that's why when I first printed everything for you guys, it was a bunch of zeros, right? I had a bunch of zeros, and then I also had the little squares down here to be able to basically tell myself, okay, at this position, at 1, 3, or at 2, 2, well, what's supposed to go there? And then after that, basically the code pretty much what it says. You can see this everything here, the solution is super simple, right? It is super simple. But that came from being able to break the problem down. And this is one of those things where I felt like the instructions were pretty vague, again, were pretty open-ended. It's not a bad thing if you're an experienced programmer, but if you're a beginner, then this could be one of those questions which is like, well, what the hell? How am I supposed to take this, to digest this problem? And this is what it is, right? Being able to look at the sample out, and thank God they gave us a sample output, because if they didn't, then we would have been Kentucky Fried. But breaking down the problem, look for patterns, look for similarities. Where have we seen this before, right? And go back into your solutions and take a look, right? If you don't want to use the GitHub repository, then you go to your TMC, all right, tmc.mooc.fi exercises, and then, right, if you go to, I'm sorry, here, for the exercises, for the courses, these are all the exercises we've done from the very beginning, from the very first video, right? These are all the solutions that you submitted, right? And well, then just go and find somewhere in here that we've seen before, right? I can click on an exercise and I can click on the details here and I can see the solution that we put. This is exactly what I have over here. But I just think it's a little bit easier for me to navigate the GitHub repository. But if you don't want to use a repository, then this is another way for you guys to find your previous solutions instead of having to go and open the workspace, the TMC workspace again. But yeah, look for patterns, right? Break the problems down into chunks. Look for patterns. Look for similarities of where have we seen something like this before, and then build on from there. Then the program will pretty much just start writing itself. As you can see again from the final solution, this is probably the simplest program we probably have written in a very, very long time, right? And we didn't need to use any fancy data structures. We didn't need to use lists. We didn't need to use dictionaries. We didn't need to use tuples. Just 2 loops, right? Nested for loops, and some basic math and some print statements, and that was literally it. So that's the solution to this exercise. I hope you guys, liked me taking some more time to give this exercise the time and attention that it deserves. I didn't think I would have done a good enough job putting it into a combined video with the previous one. So I wanted to give this exercise its own video for us to talk about some of this stuff about programming being open-ended and breaking down problems into smaller chunks, looking for patterns, looking for similarities, and then building on from there. So if you have any questions about what we learned in this video, you can leave them in the comments below. Again, I can't stress this enough. Use the Python, use the repository, guys. I always leave the link in the description below. Thank you to the folks who gave me a couple of stars. I truly appreciate it. But yeah, stars go a long way to know that people are using this as a useful resource. There's some good details in here. All the solutions we have are in here. There's still some updates I want to make to the repository, just to make navigation a little bit easier. But yeah, all of the material here is in here, all the solutions. And I have all the videos listed out in these beautiful sections for you guys. So if you want to go and visit a specific section that relates to a specific topic, you can find the video here. I have what topics are covered in the videos also listed on there. So this is a very, very useful resource that I think. So go check it out. Give it a star. I truly appreciate it. Give this video a like. If you have any questions, leave them in the comments below, and I'll be happy to help you guys out. Whatever issues that you're having, or if you're having some trouble grasping certain concepts, let me know in the comments below. After this, there is a feedback quiz that you can take. Again, I always recommend that you do take them. It helps the course instructors and the people who put these material together for us to make improvements if they're necessary, to see how people are doing, if things are too challenging or not. Um, but yeah, I recommend people take these feedback quizzes because they're very useful in improving the material for everybody else in the future. Um, so yeah, and it only takes like 5 minutes to do these. So do that. Again, thank you so much for tuning in. Check out the GitHub repository. And after this, we're going to be starting part 6. So we'll get into some of the more uh, cooler concepts in programming in Python. So I'll see you guys in the next video. I think that video should be out on Wednesday. And then we'll start part 6 on Wednesday and then go on. I hope we can finish by next week. We're leaving us with one more part 7, which has a lot of modules. And then from there, we should be ready to go take the first part exam to get our certification. So obviously, I'm not going to record myself taking the exam, but I'm going to try it myself offline, which I recommend you guys also go take. Find a scheduled time, go take it, see how you do. Again, from my research, it doesn't seem that the exam is that much more difficult than the exercises we've done. So the exercises are really, really good practice. Go back, review the solutions that you came up with, see how you can, if you could have done something differently, if you could have improved something, right? Go back and revisit them and then resubmit those new solutions and see if they pass all the tests. So yeah, that's my advice to you guys. So I have one video coming out tomorrow, I think, which is going to talk about something related to it. It's going to talk about the repository. So keep an eye out for that video. And then the video after that one, which will come out Wednesday of this week, that's going to be us starting part 6. So thank you so much for tuning in. Thank you guys so much for watching. Thank you for your support. Your feedback means the world to me. I'm happy that I get to help out, quite a bit of you guys who are also taking this course along with me. So yeah, don't hesitate to ask questions. Don't hesitate to connect with other people on here, right? Somebody asked for my LinkedIn. My LinkedIn is in my YouTube channel links, right? If you go to my channel, and guess we can do that on video. Hopefully I don't drop too many frames. Right, if I view my channel, and you can see all the links that I have, right? My LinkedIn is here, my website is on here, and my GitHub account is on here as well. So go check this out. Thank you. We've hit 60 subscribers. Thank you guys so much. So yeah, the next video will be about the repository, and then after that, we'll continue with part 6. So if you want to connect on LinkedIn, don't hesitate. I also put the link in the description below. Somebody asked me for that, I think in the previous video or one of the videos before that one, and I forgot to respond, but this is my LinkedIn. We can connect on there. I connect with everybody. So, don't hesitate to connect on LinkedIn. Go visit my GitHub profile and go check out the repository. Give it a star. Thank you guys so much for your feedback, for your support. It means so much to me. It gives me the encouragement to continue to make these videos. I mean, sometimes time is really the issue, right? Finding the time to sit down and record these videos and give them the attention and details that they deserve, so you guys actually walk away learning something instead of just watching me read and then do the exercises, right? I try to give extra context when we're learning new topics, how they relate to the real world when you're programming in the real world, if you have a job or whatnot. So yeah, I try to do my best. So thank you guys so much for your feedback and your support. It truly, truly, truly means the world. So in the next video, we'll talk a little bit more about this GitHub repository, and then after that, we will start part 6. So I'll see you guys in the next video.